Okay, here comes the next problem. For the second problem, I chose problem number 78, which is cosine of 2x times cosine x minus sine 2x sine of x is equal to 0. Now, if you look at this, the issue we're going to run into is you have two different angles being used. You have cosine of 2x, sine of 2x. Those have the same angle, but then you have cosine of x and sine of x. Those have different angles. This is where you need to start thinking about your trigonometric identities. So with cosine of 2x, what I'm going to do is I'm going to actually use one of the double angle identities there. With the sine of 2x, I'll use the double angle identity. There's only one version to use there. So my next step looks like this one. Cosine of 2x has been replaced with 1 minus 2 sine squared x. All of that is going to be multiplied by cosine. Minus the sine of 2x is going to be replaced by 2 sine of x cosine of x. All times the sine, and that's going to be equal to 0. Now we're just going to do some algebra. If I distribute in the first part, if I distribute the cosine, I'll get cosine of x minus 2 sine squared of x cosine of x. In the second part, I'm just going to multiply the 2 sine x cos x times sine of x to get 2 sine squared x cosine of x. If you notice, we've got negative 2 sine squared x cosine of x and negative 2 sine squared x cosine of x. Those are like terms. Since those are like terms, I'm going to be able to combine the two together, and I'm going to rewrite my equation now as cosine of x minus 4 sine squared of x cos x equals 0. Great. Now we're going to look for any factoring that we can do. When I look at the two terms, they both have a cosine of x, so I'm going to factor out cos x, leaving me 1 minus 4 sine squared of x is equal to 0. Now that I've factored it, I'm going to set each factor equal to 0, and I'm going to see that the cosine of x is equal to 0, or 1 minus 4 sine squared of x is equal to 0. So now let's finish solving those off. If the cosine of x is going to be equal to 0, I'm looking over here, well, that's going to happen in two places. It happens when x is equal to pi over 2, and then multiples of 2 pi. X is also going to be equal to 3 pi over 2 and multiples of 2 pi. If you get clever with your notation, you can actually condense all of that down to x equals pi over 2 plus pi k. Those are going to be your solutions to the factor cosine of x equals 0. Now let's go to the other side of the page. We've got 1 minus 4 sine squared of x is equal to 0. This is a lot like the last problem that we did. There's only two terms. There's no middle term. So I'm going to separate the terms. I'll move the negative one. I'll move the 1 to the other side where it becomes a negative 1. We're going to divide both sides by negative 4, which gets me sine squared of x equals 1/4. We're going to take the square root, remembering to have the plus or the minus sign in there. Square root of a fourth is going to give me 1/2. From there, I need to figure out where the sine of x equals plus or minus 1/2. I would draw the unit circle, and you're going to discover that x is going to be pi over 6 plus 2 pi k, and 5 pi over 6 plus 2 pi k. Those are the places where the sine of x will be equal to positive 1/2. At 7 pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k, that's where your sine is going to be negative 1/2. So that wraps up the solution to problem number 78. The last problem we're going to look at to help you get ready for next Tuesday's exam is number 41. It looks easy enough. It starts off as 2 sine squared of x equals 1 minus cosine of x. What I notice first as being a problem is that I have sines and I have cosines in the same equation. Fortunately, we've got the Pythagorean identity that we're going to be able to use. So if you remember the Pythagorean identity, that's sine squared of x plus cosine squared of x equals 1. If I rewrite that by solving for sine squared of x, you'll get that sine squared equals 1 minus cosine squared. That gets me over to here. It's this part, it's the 1 minus cosine squared, that I'm going to use in the first equation. Everywhere I see sine squared, I'm going to replace that with the expression 1 minus cosine squared. So that gets us to step 3. We now rewrite the equation as 2 times 1 minus cosine squared of x equals 1 minus cosine. We're just going to do some algebra. We're going to distribute the 2. So you get 2 minus 2 cosine squared of x equals 1 minus cosine of x. We're going to clean this up by getting all the terms on the same side. We're going to move, I chose to move the 1 from the right-hand side over to the left, and the negative cosine x from the right-hand side over to the left. After that, combine like terms, you get negative 2 cosine squared of x plus cosine of x plus 1 equals 0. Now, because I realize that there's going to be some factoring involved here, and I don't like the fact that the quadratic term is negative, that's going to make factoring more difficult, I chose to multiply everything through by a negative 1, which makes this last equation 2 cosine squared of x minus cosine of x minus 1 is equal to 0. In order to finish this problem, to solve it, we're going to have to factor the expression on the left, and this is where we always have a lot of different ways to factor. I chose to model the factoring using the master product method. So at the top of the page here, we have 2 cosine squared of x minus cosine of x minus 1 is equal to 0. The way the master product method works is you multiply the first term and the last term together. That gives you negative 2 cosine squared of x. We're now looking for factors, things that multiply to give me negative 2 cosine squared of x that will add up to the negative cosine of x, which is the middle term. Well, the factors are going to be negative 2 cosine of x and positive 1 cosine of x. We're going to use these two terms to replace the one middle term. So the new equation becomes 2 cosine squared of x minus 2 cosine of x plus 1 cosine of x minus 1 is equal to 0. Because this is a polynomial equation that has 4 terms, I chose to split it down the middle. If I look at the first 2 terms, you have a common factor of 2 cosine of x, so that's what I factored out. We now have 2 cosine of x times cos x minus 1. The last 2 terms, there is no common factor, so I just pulled out a 1, giving me cosine of x minus 1. Now that I have a factor of cosine of x minus 1 over here, and a factor of cosine of x minus 1 over here, that becomes the common factor that I'm going to pull out, leaving me 2 cosine of x plus 1 times cosine of x minus 1 equals 0. From here, we're going to set each factor equal to 0. We're going to solve it out. For the first factor, if the cosine of x minus 1 is equal to 0, that means cosine of x is equal to 1. So x will be 0 plus 2 pi k. For the second factor, if 2 cosine of x plus 1 is equal to 0, cosine of x equals negative a half. I'm going to look in quadrants 3 and 4 for my answers. If this side is negative 1/2, then this side must be the square root of 3 over 2, which makes angle theta, that's going to make our central angle 60 degrees, or pi over 3. Again, since we measure from the 0, we measure the outside angle, we're going to get x equals 2 pi over 3 plus 2 pi k. And for the fourth quadrant angle, x equals 4 pi over 3 plus 2 pi k. I hope this helps for this portion of the exam. If you have any questions, feel free to send me an email or see me in class. Good luck.